Generative AI is incredibly adept at creating a single, breathtaking still image. But the moment you ask it to hold that consistency across a dynamic two-shot scene, the illusion usually melts. This happens because AI models operate on probability. They guess what the next frame should look like, based on billions of data points. Traditional filmmaking, on the other hand, demands absolute mathematical precision. You need the exact same actor, in the exact same room, under the exact same lights, from multiple angles. Until recently, trying to force an AI into that level of strict continuity felt like playing a slot machine. If a 5-second clip was perfect except for a weird artifact in the background, you couldn't just fix the background. You had to re-roll the entire scene, burning through time and expensive compute credits, hoping the algorithm got lucky twice. Google AI uses an architectural pipeline called the funnel workflow. It forces chaotic data through SIL-twin layers, locking down variables for a controlled output. To see this in practice, we'll build a complex dual-camera cyberpunk dialogue scene from scratch. Making AI function as a dependable production tool requires stepping away from the prompt box and stepping into a deliberate, structured pipeline. The first step inside Google Flow is establishing ground truth. To prevent the characters from warping later on, you upload specific reference images. The trick here is using images where the subjects are isolated against a pure background. We tag these clean assets as our detective and our client, locking their identities as hard data points. With the cast locked, you need to block out the camera movements, but feeding complex spatial instructions straight into a flagship high-resolution AI model is a fast way to drain a production budget on trial and error. Instead, you stay at the wide top of the funnel. You run these initial tests using VO 3.1 Lite or Fast. These models cost a fraction of the compute points, acting as a virtual location scout to verify pacing and camera logic. To get exactly what you want, you use a strict 5-part prompt formula. You dictate the shot type, like a dolly push-in, followed by the locked character token, their specific action, the setting, and finally the lighting style. By separating the initial blocking phase from the final high-fidelity render, you protect your budget while ensuring the physical camera move is exactly what the scene requires. Even with a great camera move, early renders rarely get every detail right. You might get a great performance from your detective, but the window behind him looks out of place. In the past, fixing that window meant trashing the entire clip and starting over. Now, you switch the active model over to Gemini Omni Flash to handle localized edits. You don't need complex prompting here. You just talk to it like an editor. You tell Omni Flash to swap the background for a neon cyberpunk street. The model understands the context of the scene, actively shields the detective's movements, and recalculates only the pixels outside that mask. This shifts the process entirely. You are no longer crossing your fingers and typing in a prompt box. You are directing the elements on the screen, iterating on specific details until the frame is set. Once the composition and timing are locked, you move down to the narrowest part of the funnel. You push that verified draft into the VO 3.1 quality flagship model to render the final textures and accurate light physics. In this final pass, you add specific audio parameters to the prompt. You write out the exact dialogue for the detective and specify ambient noise, like low, distant thunder. The model renders the high-fidelity video, generates the environmental soundscape, and matches the dialogue to the character's lip movements. A single impressive shot is great, but a real scene requires cutting back and forth. When you cut to the reverse shot to show the client, the AI has to understand the established geometry of the room from the opposite angle. Because both characters and the environment are firmly anchored in the project library, VO 3.1 calculates the layout and maintains physical and visual continuity across the cut. Executing a spatially accurate reverse shot with generated lip-synced audio crosses a major threshold. It moves the output from an impressive moving painting into actual narrative dialogue. With the heavy rendering complete, the final polish happens back in Google Flow. If there's a minor stray object in the frame, you use the lasso tool to highlight and delete it. If an 8-second clip needs to hold just a little longer for dramatic pacing, the Extend button generates a seamless continuation of the existing footage. These polished clips are then dragged into the Scene Builder timeline. Here, you trim the handles on each clip, sequence the shots, and ensure the generated dialogue tracks with the cuts. We now have a cohesive, multi-angle scene. The lighting matches, the characters are consistent, the audio is native, and the spatial logic holds up to scrutiny. Moving through this funnel, testing cheap, editing with natural language, and rendering selectively, turns the creative process into a predictable engineering task. You no longer have to guess if the AI will give you the right result. You've built the framework that ensures it. By adopting this very strict architectural blueprint, a solo creator can maintain a level of technical consistency and narrative control that previously required specialized hardware and human teams to coordinate.